Hello friends. Welcome to our YouTube channel where we are presenting mathematics lessons. So in this lesson, which is lesson 1 and the introductory part to approximation. So we are going to deal with approximation. All right. Now, when talking about approximation, we are saying this is an act or a process of giving a measure or a value that is closer to the actual value. Right? So the measure that you give is not the true value, but you just try to give something that is closer to what is correct or to what is true. Okay. Now, under approximation, we deal with the different aspects. One of them is the errors. From errors, you look at limits. From limits, you deal with the tolerance. At the same time, you try to understand what a least unit of measurement is. After that, you also look at what we call absolute errors, relative errors, and percentage errors. It means the lesson has been concluded or the topic has been covered in full. Okay? So in this presentation, we are going to deal with two things. Understanding what an error is, as well as the limits. Okay, now what is an error? We are saying this is the difference between the true measure and the measure obtained by measuring. Alright? Is there any difference between what is correct and what you have measured? If I give you a piece of wire, which in actual sense is 3 centimeters, then you measure, you say it is 3.5. What is the error that has occurred? The error that has occurred there is the 3.5 centimeters minus 3 centimeters, which is a 0.5 centimeter. That is your error in this case. But there are times where I would want you to find the error to the nearest number, right? For example, here we are saying, in general, if a dimension D is given to the nearest n, this is the number, all right? Then the error is that number divided by 2. That is the error that is expected to occur, right? Any error within that range is okay. Now, let's look at an example of how we can find some errors of the given dimensions, right? The question reads, find the error in each of the following dimensions. Remember I said by dimensions we mean measurements, all right? So the first one is 340 meters to the nearest 10 meter. We want to find an error that can occur on 340 meters, but that error should be the nearest what? 10 meter. So in this case, to the nearest 10 meter. Here we are saying to the nearest what? N. In this case, what is our N? Our N is 10. Alright, so for the first one, I'll be solving from here. We are saying our N is what? 10. But the formula we are saying it is N over 2. Meaning that here we say over 2. Alright? And what do we get? We get 5 meters. So here, the error that is acceptable to the nearest 10 meters is 5 meters. Alright? Meaning that if you have a dimension 340 meters, the nearest 10 meter or 10 meters, the error that is acceptable or the error that might occur is a 5 meter. Meaning that from about 335 to 345, any measurement could be done and may be accepted, right? Maybe outside that could be as a result of you not knowing how to measure. So we are saying to the nearest 10 meter, so we are going to say 10 divided by 2, we get 5. That is the error that can occur there, all right? Then B, we are saying, can we find the error on 3,600 grams to the nearest 100 grams? So what is our N again? Our N is 100 grams, all right? But the formula says 100 divided by 2. So we are going to say N divided by 2. So we are going to say 100 divided by what? 2 grams, by 2, all right? And what we get? We get 50 grams. So here, the error is 50 grams. Simple. All right. We go to C. See, we are saying, can we find the error, all right, of 12 liters to the nearest liter? To the nearest liter, meaning 1 liter in this case. So we are saying our N is 1 liter. All right? So what does this mean? This implies that we are going to say the error, therefore, the expected error is 1 divided by what? 2. And what is 1 divided by 2? We have got a 0.5 liter. That is our expected error of measurement. So we have 0.5 liter of measurement. I hope that is clear. So we are saying if you want to find the error, the nearest n, you are going to say n divided by 2. Alright? Find an error that can occur on maybe 20 seconds to the nearest 5 seconds. So we are going to say 5 divided by what? 2. I hope that is clear, friends. These things are very easy. I hope you're enjoying. Alright, let's look at limits. Maybe I could erase this part so that I have enough space. Okay. We are trying to understand the limits. Remember, we are just from dealing with an error, all right? Meaning that when a dimension is given, there is what we call an acceptable error, or errors that are acceptable, all right? In this case, you are given a range. Say, okay, from this range to that range, if errors occur in that range, then they are acceptable. Outside that range could be as a result of you not knowing how to measure or not knowing what to do. All right? So that's what we are trying to understand. These limits, what are they? What are these limits? Now, we are saying, when you are dealing with limits, we are saying, for an argument's sake, if the length of a wire lies between 1.5 and 2.5, you have got the length of a wire here. We are saying it lies between 1.5 meters and 2.5 meters. This can be written using inequalities as 1.5 meters should be less or equal to the length, and this should be less or equal to 2.5. Meaning that this is the length of a wire, all right, from 1.5 to 2.5. All right? So, if you are dealing with 1.5 to 2.5, this value that is here is called the what? The lower limit. Alright? Others will call it the lower bound. It's a boundary. Alright? Okay? Or we can also call it minimum. Minimum. Then when you are dealing with this is what we are calling the upper limit. Upper limit. Or the upper bound, or max, the maximum. Alright? So the minimum is 1.5 and the maximum is what? 2.5. Okay, I hope that is clear. So if you have 1.5 less or equal to L and this is less or equal to 2.5, what we are saying is that a measurement can occur, and a measurement can be given from 1.5 to 2.5 because this is an interval within which the measurement should occur. So any measurement from 1.5 to 2.5 can be accepted. All right. But outside this, here, it means it is outside the interval, it's outside the range. Hence, that measurement is not accepted. All right. I hope that is clear. Okay, now, how do we find the upper and the lower limit? Right? That is our interest. Let's look at an example. Here we have answers. Number 1. We have a question there. A dimension is stated as 5.3. Remember, a dimension is a measurement, friends. A dimension is stated as 5.3. We have got 5.3 centimeters. There's plus or minus 0.05 centimeters. This is a measurement or a dimension that has been given. All right? Good. Now, A. We are saying, can we find the what? The lower limit. So now, how do we find the lower limit? Lower limit of a dimension. You are going to say the dimension given, which is the 5.3 centimeters, all right, plus this value that has been given. Now, this value is called the an absolute error. Of course, we'll talk about the absolute error in the next presentation, how to get that. That's the value that you use to get the upper limit and the lower limit. All right? So that's an absolute error there, or an error in short. So now, what we are going to do is, to find the lower limit, we are going to say 5.3 minus, all right, minus 0.05 centimeters. Okay? So here you do the ordinary subtraction. Maybe let me erase this. Again, we put a 0 here. All right. So you get a 1, here you have 2, there's 10. So you have 5. Of course, this will be centimeters. This will be 2.5. So your lower limit is 5.25. How did we get this minus that? All right. Number 2. We need to find what? The upper limit or the upper bound. So we are going to say 5.3. I can add a 0 plus 0.05 centimeters. All right. So here we are adding here now. This will be 3.5. This is our upper limit. Now, when you have a lower limit and an upper limit, what does it mean? You have what we call an interval. An interval is a range within which a measurement should occur. So what we are saying is that if we have 5.3 as our measurement, all right? If you measured from 5.25 centimeters to 5.35 centimeters, this could be acceptable, or this could be accepted, all right? Because it falls within the acceptable error. So your lower limit is a 5.25 and your upper limit is 5.35. But the actual measurement is a 5.3 because we are human beings, we can make errors. But again, we should have errors that we can accept. And in this case, from 5.25 to 5.35, those errors could be accepted. All right? They could be accepted. Outside that, it could be maybe the lack of the lack of knowledge of measurement, or maybe you have not calibrated the measuring instrument. Okay, so that's what we mean by the lower limit and the upper limit. Good. Number 3, or Roman numeral 3. We are asked to find the least unit of measurement. The least unit of measurement, or abbreviated by that. Now, the least unit of measurement can be found by saying upper limit minus lower limit. All right? the upper limit minus the lower limit. So in this case, what is our upper limit? 5.35 centimeters minus, what is our lower limit? 5.25 centimeters. Alright, then we do the subtraction. This will be a 1.0 centimeters, which is the same as, which implies that we have 1.1 centimeter. This is the least you can measure. Are we together? So if you are asked to find the least unit of measurement, given the upper limit and the lower limit, then you are going to say upper limit minus the lower limit. That is your least unit of measurement. Now, least unit of measurement has the same interpretation as the tolerance. Because by definition, tolerance is the difference between the highest measure and the lowest measure. So in this case, if we want to find tolerance, it's like we're asking you to find the difference between the highest measure, all right, and the lowest measure. All right, which will imply that what is our highest measure here? It is a 5.35 centimeters minus the lowest is a 5.25 centimeters. And what does this give you? It gives you 0.1 centimeter, which is the least unit of measurement. So these two, they have got the same interpretation, almost the same interpretation. So if a measurement is given as 5.3 plus or minus 0.05 centimeters, now someone says find the tolerance. All right? How are you going to find the tolerance? You are going to say upper limit minus the lower limit. First, you get your upper limit by adding this. Then you go to your lower limit by subtracting this from that. After that, you subtract the 2. So this is our least unit of measurement, which is the tolerance in this case. So tolerance and least unit of measurement have got the same interpretation. All right? Though by definition we are saying tolerance is the highest measure divided by minus the lowest measure. Okay? So sometimes these are confusing. That's why I've decided to line them up in this manner so that you see that they have got almost the same meaning. All right? I hope question 1 is okay. How to get the lower limit? You add, you subtract from the given dimension. Upper limit, you add this value we are calling the absolute error. Then the least unit of measurement, you say upper limit minus lower limit. Tolerance, again, you say highest value minus the lowest value, which will give you the same value. Okay, good. Let me go to the second one. All right. We go to the second question. A dimension is given as 8 centimeters plus or minus 0.5 centimeters. Please take note that the first one we had 5.3 centimeters was plus or minus 0.05. There's something that I will explain at the end. Alright? The second one is this one. Now, we are saying 1. Let's find the what? The upper and lower limit. So we are going to say for upper limit, what are we going to say? This given measurement by plus this. This is what we are calling an absolute error. So we are going to say 8.0 because there's one decimal place plus 0.5 centimeters. So when you add, you get your 8.5 centimeters. That is your upper limit. Then, when you look at the lower limit, again it will be 8.0 centimeters minus 0.5 centimeters. We subtract, we get 1, we have 7, here 10. So we have 5 point, this is 7. So this is the lower limit and this is the upper limit. Meaning that an error that is made, alright, or a measurement that is given from 7.5 to 8.5 could be accepted, alright, because the error is negligible. Okay, so your lower limit is 7.5 and the upper limit is, meaning that this is the minimum. You can't go below this and you can't go above this in your measurement, right? Then we need to find the LUM, least unit of measurement. That's number 2. So we are saying least unit of measurement is equal to upper limit minus lower limit. So what is our upper limit? 8.5 minus 7.5. Alright? This is a 0.1. So the least unit of measurement is a 1. Alright? Now, look. We are done with equation 2. Now, I want to take you back to this one. Remember, we got that our least unit of measurement was 0.1. But here, what is our least unit of measurement? It's a 1. Look at the dimension that we have. Here it's a whole number. It simply means that for any whole number, any number without a decimal point, its least unit of measurement is a 1. So 100 kgs has got a least unit of measurement of 1 kg. That's the least you can measure. Alright? 50 centimeters has a least unit of 1 centimeter. Are we together? So for any whole number, the least unit of measurement is a 1. Meaning that, so we are saying, if you have 8 centimeters, the least unit of measurement is going to be what? 1 centimeter. Alright? If you have 8.2 centimeters, then the least unit of measurement is going to be, because there is 1 decimal place, so you're going to say 0.1. That's the least unit of measurement. If you have 8.25, alright, then the least unit of measurement is going to be how many decimal places? 2. 0.02. Okay. This is what we'll be using in the next presentation to find the absolute error. I hope I've made myself clear there. Okay. If you have got 0. I think I could have made an error there. If you have got 0.25, the least unit of measurement is 0.01. Alright? If you have got 8.25, maybe say 3. The least unit of measurement, because there are 3 decimal places, so you're going to have 0.00 with a 1. You always keep a 1. Take note, maybe there was an error on the other presentation. Okay? I hope you have been able to pick the point. Now, let's answer number 3 with that information. Find the least unit of measurement of 8 hours. So A, you have got the least unit of measurement of what? 8 of 8 hours is equal to, this is a whole number, then the least unit is 1 hour. B, 6, the least unit of measurement of 6.3 meters. 6.3 meters. So because there is 1 decimal place, I'll have 0.1. 1 meter. Should also have 1 decimal place. C. 12.25 liters. Okay, let's write it nicely. So the least unit of measurement of 12.25 liters has got how many decimal places? 2. So you have got 0.01. There should be 2 decimal places, liters. Those are the least unit of measurements. I hope this presentation helps. Please, you can subscribe to our YouTube channel so that you keep on following and even like you place the like button. Okay, so this is where we end for this presentation, but I can give you an exercise. I'll just expose it to the camera so that you're able to copy. So you can find that one. I hope it's clear. I hope you're able to copy. Okay.